Guys, welcome to my second video on functions. This is a continuation from my last video. In this video, guys, I'm going to cover the formal definition of the function, and also I'm going to be covering the vertical line test. Okay, so with that said, let's just get started. So we are going to, let me just get to my pen here. Okay, okay, great. So let's see, what does this say? A function from a set D to a set Y is a rule that assigns a unique single element f of x enclosed in Y for every element x enclosed in D. So what does this mean? So this means that if I have a set, my pen doesn't want to be friendly today. If I have a set D and I have a set Y, okay, if I have two sets and I had elements in these sets, like if I had an element X and an element A, and here I will have f of X and f of A, then this rule says that there's a rule called f that'll map x to f of x, and it'll map a to f of a. And this rule is called f, okay? So that's all this rule is saying, okay? So every element in x, so if there's an element in x, that element must be mapped to an element in y. But, guys, this is important. There could be elements in y, for example, C, and there could be no X in D that maps to C, okay? So if we were going to do the domain and range of this, if you don't remember what the domain and range is, make sure you check out my last video. So if we did the domain and range of this function that I just described graphically above, the domain is going to be all of D, but it will include X and A. Okay, it's all of D and it would include X and A. And the range, guys, is going to be from, it's going to be part of Y. It's going to include f of X and it's going to include f of A because they've been mapped. But guys, it will not include C. Not include C, okay? So sometimes we say that the range, okay, we say that the range is a subset of Y, okay? All right, so this is a bit of theory. Let's look at some examples to help us understand this a little bit better. Okay, so let me make some space here. Okay, so I'm going to draw three examples, okay? So let's go. The first example is going to be this. And okay, so let's say I have two elements here. I have X, I have A, and I have B, and I have C. And let's say I have a mapping that brings X to A and A to C. Okay, let's call this mapping G. Is G a function, guys? Is G a function? Yes, it is, right? Because for every X, it's mapping it to a unique element B and Y, okay? So for every X in D, it's mapping it to a unique element B and Y. So for that reason, this is a function, okay? So let's look at another example. Da, 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 da. Oh, something does not want to be pretty. Okay, da, 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 da. This one's pretty. Okay, so now let's say we map X to two elements. Let's choose another color. And let's say we do this. We have a mapping that does this. Is this a function, guys? It is not a function, right? Because it's breaking our definition here. So our function, what our definition says is a function from a set D to a set Y is a rule that assigns a unique single element f of x enclosed in Y for every element x enclosed in D. So if we go back, we see that for one element x, we're mapping it to two elements in Y. So for that reason, this guy is not a function. Okay? So remember that, guys, okay? Nice. So let's move on to another example. Our last one. How about this? X, I have A, and then I map that to, and I have a B here. And then I have this time I didn't pick color. Okay, so let's say I map that with F. Is this a function, guys? Yes, it is, right? Because we're mapping X to a unique element B, and we're mapping A to a unique element B. But F could map multiple elements from the domain to the same element in the range. Okay, it could map multiple elements from the domain to the same element in the range, but it always has to map it to the same element. Here the difference is it's mapping it to one element one time and it's mapping it to another element another time. So that's why this is not a function, but this is a valid function. Okay, and if we want to see an example of this, we could just look at something simple like this, the parabolic function. Y is equal to x squared. This simple function here, y is equal to x squared. Okay, if I put minus 2 here, it'll map to 4, and if I put 2 here, it'll map to 4. So there's two elements, minus 2 and 2, that map to the same element, which is 4, right? So for that reason, this is a function. So this is a valid function. Two elements could map to the same element in the range. Okay? Okay, cool. So that's it for that, guys. So that's the theory on the formal definition of the function. And here's a little example, a couple of little examples for you to understand. If you have any further questions, please feel free to message me or comment in the section below. And I will definitely go through the comments and I'll be glad to answer any questions you guys have. Okay, so now let's finish it up, guys, with the vertical line test. Okay, so what does the vertical line say? If you draw a vertical line on a graph that contains a function, the vertical line must touch the function at most one point. Okay, so what does this mean? Let's do an example. So let's look at this line. This line is y is equal to x. Okay, that's the function. Y is equal to x. Is this a function? I don't know. This curve is y is equal to x. It is let's check if it's a function. Let's do our vertical line test. So in our graph, let's do our vertical line test. Okay, it only hit it once there. It only hit it once there. it only hit it once there. So you see, it's always only going to hit it once because it's intersecting this line at one point. When you make a straight line on a diagonal line, it's only going to hit it once. So because of that, any vertical line you draw on this diagonal is always going to hit it once. And for this reason, this is a function, okay? Because it passes the vertical line test. Let's look at another example to better understand this. Let me draw another curve, and you guys are going to tell me if you think it's a function or not, okay? So, boop, 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 okay? So, this function is y squared plus x squared is equal to 1. This curve, I should say. This curve is y squared plus x squared is equal to 1. Does it pass the vertical line test? Okay, doesn't hit anything there. Oh, it hit it once. Boom, it hit it twice. Okay, so automatically it fails. This is not a function, guys. It fails the vertical line test. You could only hit it at most one time. I'm hitting it here, and I'm hitting it here. So if it fails, if the curve hits the vertical line more than once, it's automatically not a function. Okay, and that's something to remember, guys. The representation of a circle is not a function. Okay, it's a curve. Y squared plus x squared is equal to 1 is a curve. So let's look at our last example, guys. So we're going to draw it here. This. Boom. Is this a function, guys? So this is y is equal to 1 minus x squared. Is this a function, guys? Well, let's see. Let's do our vertical line test. Boom, 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 boom. I don't hit anything. Boom, boom, boom. I hit it once. Boom, boom, boom. I hit it once. And I don't hit anything. So is this a function? There's points where I don't hit anything. Is this a function? Yes, it is, right? Because if we go back to our definition, it says the vertical line must touch the function at most 1 point. You could touch it at 0 points. Here it's touching it at 0 points. But if it does touch it, it hits it at most once. So for this reason, this is a function, okay? So it's interesting to note that the circle is not a function, but the half circle is. I know my drawing is not perfect, but this is actually a half circle, guys. And the half circle is a function, okay? So that's it, guys. That's it for the theory for me. My next video, guys, is going to be a video covering more problems. Okay, so I focused on theory for the first 2 lectures just so we could understand what we're gonna do. But my next lectures, or next couple of lectures, are just going to be me solving problems with the theory that we learned. So this is going to be very useful when you're working on your assignments, or when you might even run into some of these questions on your tests. Okay, so that's what I'm going to be covering. So as always, thanks again for listening. And if you have any questions, please leave them in the comments below, and I promise you I'll read them and I'll get back to you. Thank you, guys. Have a great one. Bye.